We're going to be looking today at solving the 45, 45, 90 triangles. But instead of using the reference triangle that has 1, 1, square root of 2, we're going to use the Pythagorean Theorem. The Pythagorean Theorem helps us to get the reference pattern. But one of the reasons I prefer people do it with a reference triangle in my class is because we have to use the reference triangle for the 30, 60, 90 anyway, and then a lot of the times they have trouble with their Pythagorean theorem with the 45, 45, 90 because it starts to throw in square roots. So we want to practice multiplying square roots, like square root of 2 times square root of 2 is the same as their square root of 2 squared. Okay, that becomes normal 2. Or 3 square root of 2. When we square it, right, it means 3 square root of 2 times itself. And we learned in my class the whole numbers multiply with whole numbers, square root with square root. We just did that. Square root of 2 times square root of 2 is normal 2, which gives us 18. So we want to make sure, if you need to watch a video, how to square square roots and how to multiply square roots. How to multiply or square a square root like we just did. And then the other thing a lot of students tend to make a mistake is when they see the Pythagorean theorem like this. So they tend to forget, or they put x to the fourth or something. So just think of x plus x. What's x plus x? It's 2x. So x squared plus x squared is 2 of them, 2x squared. Think of actual shapes. We use algebra tiles in previous years, so this would be like a long row. A row plus a row is 2 rows. A square, this is actually a real square. A square plus a square is 2 squares. So don't put 4, don't put 2 to the fourth, 2x to the fourth. These are the two things we're going to see as we get started. So here is a right triangle, and it's going to be a 45, 45, 90. They will always indicate what the sides are equal or congruent, or they'll give you that the angles are congruent, or they'll tell you, hey, this is 45, 45, 90. So there's two ways we see it. We'll see it with sometimes a square root, and sometimes we'll see it with x's that will repeat. So let's put the square root here first. 5 square root of 2, and put the x here. So because this is isosceles, we know that the other side is the same. So every time they give you one side, we automatically know the other side. And therefore we could use the Pythagorean theorem. So there's a video on that if you need to. As a refresher, the hypotenuse, or the c squared, is across from the 90. So I take the 90, go across. I like to circle it. And we're going to use the Pythagorean theorem. I circled the hypotenuse. The hypotenuse is the biggest side, which is always across from the biggest angle. So now I'm going to take the two sides, 5 square root of 2 squared plus 5 square root of 2 squared equals x squared. And so students sometimes don't remember how to square square roots, especially with a whole number. So this means 5 square root of 2 times 5 square root of 2. And once we do one, we'll know the other one. So like we said, a whole number multiplies with whole number. And square root with square roots becomes square root of 4, or normal 2. We need to get used to the idea that any square root times itself is the same as 2 of them. So we take it out of the little umbrella. It becomes normal 2. So 25 times 2 is 50, so that was worth 50. The other one was also worth the same. It looks the same. So we get 100. So when we're reducing the squared, because of the squared, we use the inverse, the opposite. In order to make it just 1x, we square root both sides. The opposite of squared is square root. That gives us 10. 10 times 10 makes 100. So we didn't need to break it down all the way, but if we did, it's okay. It would be 2 times 2 times 5 times 5. We take out a 2, we take out a 5, we would get 10. Okay, but the main idea that people tend to make a mistake on are they don't know how to square a square root. We multiply a whole number with whole number, square root with square root. Sometimes when you repeat a square root twice, the square root disappears. So whole number with whole, and the roots with the roots whenever we're multiplying. Multiplying. So let's try one or two more examples. We'll try the second example where the x is going to be where the side is instead of the hypotenuse. We're going to get a slightly different situation. And we won't always see the square roots. So here's another one. Put an x here, make it 10. So this one will be the same actual problem, but working the other direction, looking for the side instead of the hypotenuse. So again, if we have our right angle here, we can find our hypotenuse across from it. So then the A would be x, because that's the spot where the side is. Now, since we know one side is x, the other is the same because they're isosceles. These 45, 45, 90 triangles always have the same sides. So we're going to put x squared plus x squared, that's the two sides, equals 10 squared. That's what we had in our triangle. The two sides were x, and the hypotenuse is 10. So here's where people make a mistake. At the very beginning I mentioned, this is like a 1 and a 1. 1x squared plus another x squared means I have two squares, 2x squareds. Now I'm going to divide by 2. X squared equals 50. And we square root both sides in order to get x by itself. So the square root of 50, if we factored it, is 2 times 25. Square root of 25 is 5, we know. That's going to be the answer. And so if you see the square root of 25 is 5, you can just take it out. We don't need to keep reducing it. But the factors of 25 are 2 times 5 times 5. You can put it in the calculator to double check to make sure you always factor correctly. So 2 times 5 makes us take the 5 out, right? The square root of 25 is 5. Then we had the 2 that's left over. We leave that in the square root sign. So a 45, 45, 90 triangle can also be done with a Pythagorean theorem as long as we know how to use multiply square roots, square them, as well as how to add x squared plus x squared. So let's try one more. Let's try one with both of those situations. So again, since this side is x, the other side we know would be x as well, because both sides are always the same in a 45, 45, 90. Across from the 90 would be our hypotenuse. So x squared plus x squared equals 5 radical 3 squared. X squared plus x squared, we just learned is 2 of them, 2x squared. And 5 radical 3 times 5 radical 3, we multiply whole number with whole number, 25. Radical 3 times radical 3 is normal 3. Radical 9, which is normal 3. So 25 times 3 is 75. Oh boy, so this one ends up with a fraction, or a decimal, but that's okay. We'll just we'll leave it as a fraction. So last step is divide both sides by 2. Oh boy, this will be good to practice a lot of important stuff. So 2 divided by 2 cancels out, and we have 75 over 2. So now we can square root both sides. Oh, now we have the whole thing square rooted. So one thing that we learned that's good to review, I wouldn't probably test this unless it was bonus, especially during lockdown, but what we have on top, we can separate the square root sign on top from the square root sign on the bottom. Okay, then we get to do what we've been practicing, rationalize the denominator. So square root of 2, square root of 2. So the top becomes the square root of 150, because the square root of 75 times the square root of 2 is the square root of 150. I don't have to put it together since I'm going to factor it anyway. I could just leave it 75 times 2, put it under the same roof. And square root of 2 times square root of 2 is normal 2. So then we need to factor 75 is 3 times 25. We're done factoring 3. 25 is 5 times 5. So the factors of 75 are, I'll put them down here, 3, 5, 5. 3 times 5 times 5. Times the 2 that we had next to it. So the last thing will be to take out the 2 5s as a pair. So the final answer would be 5 radical 6 over normal 2. So that's a nice, good, challenging one because you had to do the Pythagorean Theorem. You had x squared and x squared, so it's 2x squared. It's something to remember, how to add the x squareds. You squared a square root, you reduced the square root, and then you rationalize the denominator. So that's something that, right, in Algebra 2 we would want to make sure you can do is multi-steps, not just the first couple of steps. So if you could do this problem, you're doing pretty good. If not, we just need to review a bit more in practice. So I hope this helped.